And to it's good to see such a great crowd and to see a lot of our faculty from ICS coming and joining us. This is great. So as you guys already know, but for those who might not, this is Dr. Lucia Lin, who is going to give us a talk on blockchain. He also helped us to be Kelsey's dissertation chair. And so we're really excited. And as I told Rich, everything is blockchain. Blockchain is the secret to everything. All you have to do is read your email, read all the IT news. So now what we're going to do is get a little bit idea, okay, what is it that is the solution? So thank you.
Okay, thank you for having me. So I'm going to talk about blockchain. This is going to be an applications-focused talk. I did give a technical how blockchain works type of talk last semester in March. So I'm not going to repeat that because it turns out it's fairly complicated. Okay, but I'm going to talk about applications, and this is kind of fun too. So what is blockchain? Blockchain started out as the distributed ledger. This is a kind of a term that came out with it as well for Bitcoin transactions. Okay, these are some of the properties. It's a distributed. In fact, it's a P2P database. So the database is distributed over thousands of P2P nodes. I checked yesterday. I believe the number of Bitcoin nodes now, it's almost 10,000. It's like 9,000 something. All right, but that's a huge number. Decentralized, no single entity owns more than 51% of the nodes. Fully replicated, every node keeps a full copy of the data. This is an important one, immutable. Committed transactions cannot be modified. This is achieved cryptographically. It's achieved by chaining a bunch of signatures from blocks to blocks together, making it almost impossible to change. I mean, nothing is really impossible, as we know. There's always a hack around it, but it's difficult enough that it's pretty hard. The Bitcoin version is transparent. Transactions are visible to everyone, right? As long as you have a Bitcoin node, in principle, you can see what transactions is happening. You may not know who the identities of the parties transacting, but you know what the transactions are. Anonymous, what I just said, the transacting parties, they only use their cryptographic keys as their IDs, so you don't know who they are. Okay, and in fact, Ado made the comment last time I said that the anonymous founder inventor of Bitcoin, Satoshi, nobody knows who he is or she, or may not be a person, maybe an entity, and apparently he owns the first 1,000 Bitcoins, which are worth a lot now, right? It's relatively secure in the sense that cryptographic techniques are used to ensure that only the owners of the Bitcoin can make payments. And then mining is the process, very interesting process. It's very hard. It's a cryptographic procedure in the commit process of the transaction. So in order for a transaction to be fully committed and incorporated into the blockchain, there's this process that someone has to mine. And what mining means is it's computing a cryptographic hash with certain properties on that block of data before that block of data is chained to the rest of the blockchain. All right, once it's chained to the blockchain, it's very difficult to modify it, unchain it, change it. That's the immutable part. All right. Yeah.
Can you
go ahead.
define ledger?
Oh, ledger. This is like to me, ledger is like an accounting term. It's like I know back in my undergrad days, for my computer science degree, they make us take. I had to take one management course, I had to take one accounting class, and the accounting class was, tedious. Right? Because one of the things that you do in accounting is you record all the transaction that happens in what do you call it? Do you call it a ledger? Do you call it a
Yes.
journal?
Like a general ledger.
A general ledger,
Oh,
exactly.
That's what.
Right? So it's that concept. I record everything in my general ledger, every little bit
Is
of
the
money
books-
that's spent.
The book of the transaction.
Yeah, the book of transactions.
Okay.
So this is like a book of transactions.
Okay. So,
Yeah. Good question, really. So this is just a quick visual overview of how it works without really going to how it works. So I know that Ado spoke last week, which is great because I think we talked about P2P networks, hopefully. So Bitcoin or blockchain are based on P2P networks. So we think of this as sort of the P2P overlay network of these are your blockchain nodes. And even though it's a link here, this may not be a direct link. It could be over many hops. All right, but we think of it as a link. This one's an overlay network, right? So what happens is that there are two types of messages that get sent out in this Bitcoin blockchain network. All right, one is transactions. So you have these wallet applications, your wallet clients. When you spend Bitcoins, right, you send sort of transaction data, right, to one of the nodes. And what this node does is that it's going to, using these P2P type of broadcasting, basically passing the messages on, it's going to broadcast this transaction to everybody. All right, essentially, right? So that's what's happening. I'm going to show only one set of arrows here, even though it will then recursively spread to the rest of the network. All right. So everyone is going to keep a cache of this transaction. Okay, for now. So maybe this other person spent some Bitcoins, so the messages propagate. Same thing, propagates to all the network, all the nodes. And then at some point, some nodes, when there's enough transactions to form a block, right? The mining nodes are going to come and grab this block of transactions, and it's going to start to compute this cryptographic hash on the signatures on this block with certain properties. All right, and everyone is going to, all the miners are going to race to actually do that. Okay, because see, everyone sees all different transactions, so everyone knows what's happening. So they're just going to grab a block and try and compute this cryptographic hash. At some point, one miner is going to succeed. Sometimes two, right? But most of the time, there's a way to break ties. But just for the simple case, one miner is going to succeed and is going to be successful in computing this hash. And at that point, that block gets incorporated into the blockchain. All right. Once it's incorporated, it's still not the end of the story. You actually wait for other blocks to be chained behind it. So the more blocks that are chained behind it, the more entrenched this block is into the chain. And once it's very entrenched, it becomes very hard to break, or very hard to modify it or change it. Okay. So at a 30,000 feet level, this is how the Bitcoin blockchain works. All right, without going into details.
Can I ask you just one
Yep.
quick question?
Yes, absolutely.
So, how long does this take before a block forms? Are we talking milliseconds? Are we talking days, weeks, or months?
No, we're talking about milliseconds.
Okay. Because it seems like one of the weaknesses can be at that first node. Could they corrupt the transaction at that point?
Possible. In which case, well, the protocol is such that it will broadcast stuff.
Mm-hmm.
So as long as enough people get the correct transaction, they're probably okay. But yes, it's possible.
But so, for example, say I am going to buy something with Bitcoin, so I send a transaction to reallocate my Bitcoins from me to Katrina, but the node I send it to says, no, I'm going to redirect them to myself. How does the blockchain prevent that from happening?
Well, it cannot really do that unless it has your credentials, because all of this is cryptographically signed.
So it can't open up my transaction. Thank you.
I mean, it can see what's happening, but there's this whole authorization mechanism built into blockchain transaction that ensures that these cryptographic conditions have to be met.
So without my cryptographic signature, so to speak,
Yeah.
it can't go in. It can't go in and erase Katrina's name and put.
No,
somebody
it
else's
cannot.
name. Okay. Thank you.
Yeah.
Wi- Without your recipient's secret key.
Yeah.
Okay.
That's, when you create a transaction, you have to know the secret key of the person you're giving the bitcoins to. And you have to know their
Public key, yes.
And only the person with the corresponding secret key can spend
Yeah.
those bitcoins.
Of course, this doesn't prevent phishing stuff where I deceive you into using
No, I understand.
my public key, right? Because humans are the weakest link, right? Unfortunately, I know, I hate to say that.
But sorry, you
Yeah.
need so you need enough people to use it to form the block and to form the chain. It's like if it wasn't much used, it wouldn't work at all.
To some degree, this is like the chicken and egg problem. Maybe that's why the first 1,000 or so transactions is by the owner.
You took the launch it.
There's no minimum block size. You can have a block
okay.
with no
Yeah.
transactions.
Yeah.
Okay. Okay.
So once the block is mined and incorporated in the blockchain, that block is then broadcasted throughout everyone. So everyone then keeps track of what's happening. Okay? So that's as much as I'm going to say for that. Now, a couple of myths, actually it's mainly the first one, because interestingly, I still get people come talk to me and say that they think that blockchain and Bitcoin is the same thing, which, I mean, understandable, they are very related, but they're not. So one myth is blockchain cannot be used without virtual currency. That's not true. All right, blockchain is somewhat like the database technology underlying Bitcoin. All right, but in a sense, and you're going to see that what's happening is that now a lot of people are pulling that piece out, in fact, modifying it and using it in all sorts of applications, as we'll talk about later. So blockchain cannot exist without the Bitcoin blockchain. Not true. We have many other blockchains coming up right now. Transactions on blockchain cannot be regulated. Not true. Of course it can be regulated, depending on how you sort of manage the whole ecosystem, if you will. Of course, in the Bitcoin case, it was designed so that the transactions, the payment of Bitcoin can be performed without the need to go through a third party. All you need to know is, if I have a Bitcoin, I want to pay somebody, all I need to know is the public key of that person. And I could make sure I have Bitcoins, because it won't let you pay anybody if you have no Bitcoins, right? So blockchain makes transactions nearly free. We know it's not true. Even for the Bitcoin case, the mining actually uses up a ton of electricity.
That's the thing that I'm feeling now. Like there's big rumors, like
Yeah.
lots talk about the amount
Yes.
of energy it takes now, and that seems to be the thing that people are more worried about now.
And in fact, what happens is that the Bitcoin system is built in so that, I shouldn't move around so much because she has to she has to move the camera. Because they make the level of difficulty for the cryptographic hash for the block harder and harder as you go along. So it's going to take more and more computational resources to actually compute the blocks. But let's move on, because why is this relevant to us? Very interestingly, in March of this year, it's going to change the world, kind of. That's the hype, so we know that. But locally, right, the state legislature, there was a bill, HB 141, HB 1, that basically says that the legislature would like to set up a working group to study the uses and best practices regarding blockchain technology. Okay, so this is, I think this is in the Ways and Means Committee right now. I'm not sure what's going to happen after that. We'll see. I don't know much about the legislation. Maybe Stephen will have to tell us more about that. I'm not sure what the next step is in terms of this bill, but it has certainly been quite far along. Okay, how is blockchain different from traditional transactional database? Right? It is. These are the couple of things that I think are interesting about the Bitcoin, about blockchain. Sorry. Right? Data is fully replicated in each node. Means every node has a full copy of the data. All right. This has some nice properties, right? Each node is owned by a different organization or entity, right? At least with the Bitcoin case, it's true. And those entities may not trust each other. They may or may not. Okay. Every node can see the entire database. All right. Once a new transaction is committed, the data is permanent and cannot be changed. This is cryptographically guaranteed. Not so true for most traditional database. And then cryptographic techniques are used to ensure transactions are authorized by authenticated parties. Right? Another cool feature. And any node can commit transactions without central authority. All right, this is the decentralized part, which is probably what freaks most governments out as well. Yes.
So I know in the 90s they were talking about how they're like mainframes were going to go away. Do you think that this is very similar to that same idea, or like the technologies that are pushing it away from mainframes?
No, not really. I don't think. I mean, mainframes, that's a separate discussion, but you're talking about whether this is going to make all the central regulators go away. Probably not.
It's more about banks going away than mainframes.
Yeah, but now the banks are jumping on board, right?
Yes.
They right. If you can't kill it, you join it, right? If you can't. Okay, this is a slide that I kind of modified from this link. This is the Bitgeist. Bitcoin was, the white paper came out in 2008. The implementation came out in 2009, I believe. And since then, in the early years, right, the conventional wisdom is, hey, Bitcoin is for drugs, it's for the shady stuff. Right? And then 2015, there was some talk about, hey, blockchain is going to change the world. And in 2016, we have widespread adoption is maybe a decade out. But guess what? This year, it's crazy. There's the amount of proof of concept that's happening in the industry is just amazing. Almost every bank is looking into this. Almost every financial institution is looking into this. There's a ton of startups that are looking into this. All the big companies, the big consulting companies, Deloitte, IBM, they're all looking into this. They all have some proof of concept going, as you'll see, because this is what I'm going to go through in this talk. These two are sort of my predictions. 2018, I think we're going to see commercial blockchain products, and companies are going to start to adopt. 2019, I think the government sector is going to start adopting it. I put this point here because that these slides were originally created, well, parts of these slides were created for a talk that I was supposed to give in Shanghai 12 hours ago, but obviously I didn't because I'm here. Somebody else is giving a talk for me. But that was mainly on sort of government sector. So this is dated in March. These are some of the Bitcoin and blockchain companies that's happening, the startups, and you can see it's everywhere in the world. You have something going on. That was in March. Now there's more. So what is a blockchain? It's a database. That's it. It's just a database, right? It's the database or ledger of transactions with these properties, and we saw some of these already. Distributed, replicated, is append only, immutable, decentralized. It has the appropriate authentication, appropriate transparency, appropriate anonymity, right? So these three or these four governs of the openness of the data in the blockchain. Deals with a lot of trust issues. In fact, sorry?
Append only?
Append only means that I can only add data to it.
Oh, never.
I cannot delete, I cannot update, I cannot change, right? The first couple you probably can do with the traditional database technology in some form. These a little bit more tricky to do with traditional database technology. Again, these deals with levels of trust, and also the cryptographic techniques gets employed, which I'm not an expert in cryptographic techniques. We should talk to Dr. Lee, Professor Lee. He probably knows more about those than I do. How does it work? Like I said, I'm not going to talk about this. I do want to leave with a couple of questions though. How do we get critical mass of peer nodes? We need that. How is consistency managed? Who can perform transaction? What info is public? And what is hidden? A couple of questions to keep in mind. For technical details, you can see my earlier talk, which I also recorded 6 months ago. And it's much more involved. So, beyond Bitcoin, what's happening? Well, we have the blockchain in Bitcoin is often called a public blockchain, or let's call it a unpermissioned, I think, blockchain. Right now, for the commercial side of things, we are seeing what's now called private blockchains, also called permission blockchain. And why is the word permission there? Because in the it's permissionless. So the public one is permissionless because you don't need a permission to actually get access to the blockchain, right? Whereas the private one, it's permission. So you need permission in order to see what's going on inside, or to even access it, or to commit to it, right? So that's because for commercial applications, you require that only selected entities can be a peer node. You can't let just anybody join. That's going to freak everybody out, right? So that's one of the big modifications, right? Private blockchains. This will impact on the number of peers. And the number of peers does impact on the fault tolerance level of the blockchain. The replication append only immutable properties, they remain, but the consensus protocols becomes configurable. In the blockchain, in the Bitcoin blockchain, the consensus protocol is essentially the mining guys. The mining guys will compute the cryptographic hash for a block. And that's supposed to be difficult. And people use FPGAs and ASICs and all sorts of compute-intensive hardware for it. It drove up the price of AMD and NVIDIA stocks, by the way. So significant, right? So that's often called proof of work, right? It means that you prove that you have done so much work, and therefore this block gets committed. But now in the private case, blockchain, the consensus or the commit rule becomes much more configurable. You can configure what's a commit rule. You don't need to rely on mining, because relying on mining is, first, it's slow, and secondly, it's compute intensive. So there are other consensus protocols, right? And this could be based on like if a majority of the stakeholders would sign off on this transaction, it's considered committed, for example. That's a very simple example. Anonymity is less important, right? But privacy becomes much more important. You don't want this. You don't want your transaction data to be public, right? You want it to be much more private. So transactions can be encrypted. There's all sorts of techniques for that. Authentication is still important, right? Obviously, right? These are some of the private blockchain technology that's around. And I'll mention those in a little bit.
I have a question.
Yep.
You mentioned that there is proof of work for every transaction that's happening,
No, it's for every block.
but blocks are
Blocks
created for
consist
each
of transactions.
I thought
Yeah.
it was only for generating, let's say, Bitcoin applications, for generating Bitcoins, but for paying someone, that's...
But that is a Bitcoin transaction. So any payment, any transfer of Bitcoin between two parties is a Bitcoin transaction.
That's transaction, but
And transactions get packaged into blocks.
I thought generation of Bitcoins was... the
Generation of
proof
Bitcoin is, at least for the Bitcoin case, is they have a rule, and this is the cleverness of the Bitcoin system. Is that they built in this incentive that if you manage to mine a block, you are rewarded with some amount of Bitcoins. Okay, so this is built into the Bitcoin system. If you successfully mine a block and that blocks get incorporated into the blockchain, you, the miner, the person who does the mining, so you need to supply your public key credentials. You get paid, and you create that Bitcoin. You get paid with that. So that's the motivation why everybody was trying to mine Bitcoin. In fact, last time I gave this talk in ICS, a couple of our students were involved in mining for Bitcoins. Of course, they found it increasingly difficult when they start upping the standards. So eventually they gave up because electricity in Hawaii is not cheap. Yep.
Another question about consensus. You mentioned that there are only 10,000 miners out there right now.
There are 10,000 nodes. I'm not sure how many miners are there.
So fewer, less than that? Or
Probably less than that.
So, okay, so then if there are 10,000 nodes, it's not completely unbelievable that if there is a bad actor, who, let's say state actor, who wants to undermine this, generate or create 10,000 nodes,
Yeah.
it already affect the consensus.
Absolutely. But it hasn't happened.
That seems very secure.
Agreed. Like I said, it's all possible. If you have the resources to hack into more than 51% of the nodes and take
No,
over
not hacking.
51%,
If you can create new nodes.
you
and
can create.
generate
If you have the
new
resources to
nodes.
create that, in principle, you could influence it. You could change things. Yeah. Absolutely. Okay, from the business process point of view, right? Business process point of view. If you, I should have made this an animation. This is the traditional way of business processes. So in a very generic sense, right? Whenever you want to, say you're buying a house or you're entering into a contract with another company or something, right? You have your records, party B's records, you have the bank's records, you might have an auditor's records, or in the law department, or in your lawyer's place, and you often go through some kind of a clearinghouse, right? You need a lot of coordination between the different parties, right? You go through a centralized clearinghouse in order to get that transaction done, all right? This happens more often than you think in businesses, in government processes, all right? What has changed, or what could change with the blockchain is that this goes away. Your central authority goes away. Instead, you have your blockchain, and all your stakeholders have maybe nodes, maintain a peer node in the blockchain. All right, and when you want to perform a transaction, you just do your digitally signed encrypted transaction, I mean, this is a digital signed ledger of a transaction, but all you need to do, you just commit. You just send out the transaction to the blockchain. Once the consensus protocol approves it and it gets incorporated, it's final. Okay? And all parties will see the same replica of the ledger. All right? So there is consensus, there's provenance, there's immutability, there's finality. Yes?
This is suddenly starting to sound like web services to me. That because blockchain, the Bitcoin already had a set of assumptions about what we were transacting, which was financial.
Correct.
And its value or valueless depends on eventually on the people's belief in it, but then the ability to exchange services in the real world, right?
Yep.
To somehow get those.
Yep.
But now when you're talking about these blockchains and business processes, I'm just thinking about, like, you have party A, party B, bank records, auditors. There's so many different factors involved. All of a sudden I'm thinking about XML and
Yep.
all the kinds of things that would have to be defined within a domain before the blockchain, which is simply technology,
Yep.
could actually be helpful. And
You are absolutely right.
well, I didn't think that. I wasn't thinking that coming in, so it actually moved me a big block in my blockchain. Okay, thank you.
I'm going to talk about that in a little bit. Okay, but before that, just the lay of the land, right? These are the current blockchain consortia and implementations. So these are the current implementations that are being used in proof of concepts. Utility settlement coin, this is led by UBS Bank. It's a consortium of 5 banks. Global Payment Steering Group, and a 6-bank team. Chain, 9 banks, financial institutions. So you can see, right, it's a lot of it, because Bitcoin is so close to financial industry, right? So of course the financial industry jumped upon this first. So a lot of the consortia are by banks and financial institutions. But, right, with Ethereum, you start to have a bit more diversification. You have more consortia of both banks and non-financial companies. R3 Corda, there's also financial companies. Ripple is a bit more diversified. Hyperledger, very big, 122 companies, various industries. IBM joined this, and IBM donated its blockchain implementation, Hyperledger Fabric. This is also used a lot in the proof of concepts as well. Okay, this is where things get interesting. So what are the usage patterns that we see right now? Essentially, even though blockchain sounds sexy and all that, all it boils down to is blockchain is being used as a shared master database that's immutable and that provides a single view of the truth among diverse, possibly non-trusting entities. Okay. In a sense, that's all it is. But when you think a little bit harder, or if you have worked with many agencies and companies, you would find that this is actually quite amazing, because one of the biggest problems in anywhere in terms of government or even private industry is data exchange. It's not easy to share data. It's very hard to share data. That's why one government agency doesn't talk to the other. Right? Because it's so hard. So here you have a piece of technology that could potentially let 2 non-trusting agencies share a common database. That could be quite powerful, as a force in society. Okay, so keep that in mind. So what does this mean, right? So of course, business and financial transaction, that's a no-brainer. But now we're thinking about provenance, that a shared database could provide sort of provenance. For provenance, we mean being able to trace how the transaction happened. And we're going to see an application of that. Health records. If you're with Kaiser this year, your health records are with Kaiser, and next year you switch to HMSA, chances are your HMSA provider won't have access to your Kaiser records. Okay, unless you explicitly request, take a DVD from the Kaiser records and give it to your HMSA side, right? And people have looked at this for many years, right? Some of you have worked in medical informatics. They have looked at this for many years. At some point, Microsoft wanted to do something with its Vault, I think, but never really happened. So now people are reopening this discussion. Maybe we could use blockchain as the way to store medical records, and this blockchain is accessible by all medical providers, and hence there's a single view of your medical records across all providers. Okay, something to think about. Identity. This has by identity I mean passports, IDs, right? Storing your identity, who you are, proving who you are. All right. That again, interesting, because right now, even between states, there is not much sharing of identity information, right? And of course, I mean, there are those among us who are like, no, we don't want to share, right? Because it's like a big brother thing, right? You don't want a big brother looking over you, so it's better to keep my identity local. But if you want to share, if you want to make your identity easily, transferable between states and all that, then maybe blockchain is the way to go. So this is the predominant application pattern right now. All right. There's also talk about smart contracts, but we haven't seen that many proof of concepts in this area. So the smart contracts, the idea of smart contracts is that there is logic associated with your contracts or with the transactions. All right. And that means that there's logic in that something is going to execute when you fulfill certain conditions of the contract. Automatically, it will execute something. Like you will execute a transfer of bonds when you've met certain conditions. All right. So that's the notion of smart contracts. Notion of smart contracts by itself is not new, but trying to do it in the blockchain is kind of new. All right. Okay. Right now, I'm going to jump into a whole bunch of use cases. First one is IBM and Maersk, shipping company. They aim to get 10 million shipping containers into the global supply blockchain by the year end. What does that mean? It means basically this. They have a proof of concept going using Hyperledger Fabric to manage transactions among a network of shippers, freight forwarders, ocean carriers, ports, and customs authorities. So this includes government agencies, all right, across borders, right? So this is interesting now. We have a shared database of all the shipping containers, what they contain. A shared database that's shared not just within one country, but across different countries, different ports, across government agencies like custom and border control, sharing that with private shippers and freight carriers. Okay, that sounds pretty big to me. So what's in the blockchain? Shipping data. What's the value? Establishing transparency among untrusted parties. You'll be able to reduce frauds and errors, reduce the time products spent in transit and shipping process, possibly improve inventory management, reduce waste and cost. Yes?
All this information is available to all these players who didn't have it before. Are there privacy concerns about that? Or?
Probably.
Yeah.
Yeah.
But
So
wouldn't that data be encrypted? So even though you could see the blocks, you couldn't necessarily see what's inside the blocks. So you couldn't, like, if
Yes.
I'm a company and I'm shipping with another company, you can't see what I'm actually shipping.
yes. So there can be access controls built into it so that it's not free for all. It's not that every company can see every company, right? There can be access controls built into.
That's what I was
Yes.
thinking about, yeah.
Yes.
So I don't know if this is relevant or not because this is kind of out of my wheelhouse, but if it's not centralized and someone were to hack that information, then who's responsible?
Good question. The question then is also that if they're able to hack one node, it doesn't matter. There's enough redundancy in the system that it can survive that. But as Nodari pointed out, if they manage to hack the majority of the nodes or engineer a majority, then we might be in trouble. Yes.
This might be a dumb question, but what I keep thinking about, you said it's append only, so you can only make a transaction and then it becomes part of the permanent record. Humans make mistakes all the time. So
Yep.
how does the system account for human error?
That will have to be designed into the data model. So you might be able to make it's going to be like when people publish a book and then they publish errata after that, like corrections to it. It's going to be something of that sort. Because it's not going to let you go back and change any records. Yeah. So that's going to be built into the application somehow. Yeah.
This is ultimately has to be a socio-technical system, right? Because what I'm thinking here is that when I decide to ship something, when I first containerize it, a government official comes, looks at it, they sign off for it, and now a transaction is created, and that transaction now becomes immutable. So somewhere along the line, somebody else can't come in and
change it. Yeah.
take my container number or change what's in the container. So I
Yep.
think I could see that as really being a way to tackle the fraud and some of the issues of shipping. But
Correct.
you're still going to have outside agents at some point verifying the
Yes.
initial transactions or where
Yes.
the physical thing. When you're adding transactions into it, they're going to
Yeah.
have to be humanly verified.
Exactly.
Right?
Yes.
Or
So
automated, little IoT.
yeah, another way of saying that this is just the underlying technology, right? But you still need all the administrative controls, all the controls in the business processes that is using this system. There's no getting around that. Of course, with this, maybe it might simplify some of it because of the ability to share information, but you're not going to get away from, not having the checks and balances and all of that. And again, like you said earlier, I forgot to mention it, right? You still have to tackle standardization of the data models for the data exchange, right? We need a common data standards, common vocabulary, common terminology, common way of encoding things. You can't avoid that. Doesn't go away, unfortunately. Okay, this is a Walmart pilot, and they are piloting blockchain as a way for food safety. Of course, they did it both in China and USA, and of course in China this is a big deal because some of you might know that in China there is a lot of counterfeiting of food, fake rice, fake eggs, fake milk powder. It's just crazy, right? So Walmart is testing a blockchain for tracking food, right? So what you can do with it is that so this is the provenance part, right? But with this system, scanning a label of the label of a packet of sliced mangoes in the U.S. can reveal the origins to 2 farms in Mexico and the stops along the way. This can be done in 2.2 seconds compared to 7 days previously when you had to pull up all the paper records. Okay. What's in the blockchain? Food processing and transportation information. and basically product information, the farm, the batch numbers, and so on. Peer nodes is going to be all the partner companies in the food supply chain, right? So all those guys will need to be on board and be running peer node. I'm going to jump ahead on some of this since I'm running out of time. So I'm going to just quickly talk about this. So this one is China UnionPay. They basically put loyalty points. Think of loyalty. In fact, if you think about it, loyalty points, like just like if you Safeway points or whatever. Almost every store has their own point system, right? It's a bit like currency. So not surprised. Easy use case, because it's a bit like currency. You spend it, you earn it, you spend it. But the interesting thing is that the peer nodes, right, all partners, supermarkets, places where you can spend the loyalty points, and places where you can earn loyalty points, they have to be on board with the peer nodes, with the blockchains. Okay, pretty cool stuff. Closer to home, Illinois, the state of Illinois has unveiled a blockchain initiative just last month. Right, they're piloting a bunch of stuff, but the most prominent one is digital identity at the birth registration process. So whenever you register birth, right, means baby gets born, right? A transaction or the birth information gets encoded or gets committed into a blockchain. And they're partnering with this company called Evername, which does self-sovereign identity. It's very interesting. It's a digital identity solution that the identity remains entirely under the individual's control. Okay, so what this means that it can efficiently and securely be validated by entities who require it. All right. So, but you are in control of that identity. All right. So that's what this company provides, and it's partnering with Illinois for that. All right. So the hope is that if you have something like that, then maybe all the various state and local government agencies will be a peer node of this blockchain and would use it to do all your identity verification, authentication, and all of that.
What does it mean you're in control?
Sorry?
What does it mean you're in control?
Good question. I don't know the specifics, but I think what it means is that you can decide how their identity gets used. Basically, it's like authentication, right? Identity used to authenticate you.
But once the data is there, you cannot remove it.
True.
So if you need it for something but not other things,
I think that's something that depends on what this company provides. They may have a way to provide so that you can say, I only allow my identity to be used by this agency but not this agency, and so on. So something that basically you have a say in how your identity is used.
It has to be done, I don't know the details either, but it has to be done in a way that's not transferable.
Yeah.
So I can prove to you who I am, but you cannot use that information.
Yeah. Again, I'm not the expert on this, so. Bunch of initiative in Dubai as well, and this one is sort of less developed. It's kind of still in the idea stage, I think. So there's a lot of talk about it. There's a bunch of there's 7 POCs that's happening. And I'm not going to go through it, not so interesting. Singapore Central Bank trying to do a digital version of their currency. Again, a simple one. Japan is doing something with the government procurement systems. So all the government procurement, the tenders and the bids will go into a blockchain. The Australian Securities Exchange is trying to roll out a blockchain-based equity settlement and clearing system. Again, this is financial, so very similar to most other cases. Okay, So that's it. That's all the use cases that I'm going to talk about. I had to zip through them, sorry. But I would like to, again, open up this time, especially given this bill. And now that you have seen some of the use cases, well, first, any questions, comments, and secondly, what do you think this technology can be used in Hawaii, in the state of Hawaii? Think about it.
Yeah, first I have a question. I don't see how it solves the data sharing problem in any way, because it seems like the financial transaction is the simplest.
Yes.
You know, a person, two people and an amount, and that's it. But once it becomes more complicated data, then you have to start deciding on what data is included and what form it's going to be in and how it relates and all that sort of stuff. So then that all of a sudden seems like it brings all of the data sharing problems back into the blockchain.
Yeah, it doesn't solve the data standardization problem,
Yeah.
which is one of the big things in data sharing. But it does help in the ability to have a common database that is distributed, and in a sense, the stakeholders have equal ownership of it in a way. Because again, if you work with many government agencies and some of the private as well, one of the big things with sharing data is like if you say that we're going to have a central database that is shared, then okay, who's going to host this database, right? If it's company A, then company B will get suspicious. If it's company B, then company A will get suspicious. So there's these complicated trust issues, right? And so I think this addresses that more so than the data standardization issue, which I agree with you is not solved, right? But definitely being able to say that, okay, we are all equal stakeholders. We all see the same data, right? And the data is cryptographically guaranteed to be immutable, right? So I think that's very powerful. Yes, this.
I was going to say, it seems to me that the area where this could first take off is areas where you already have a high degree of data standardization, limited data, highly standardized, like in certain kinds of transactions, certain kind of identity issues, or even real estate transfers or stuff.
Yep.
So where you already have high levels of standardization and you have a hated central coordinator. And when I say hated, like all of the units around them are forced to work with the central party and would prefer to not. Maybe the cost is too high or the service has been bad. Because then basically that's how Bitcoin was fairly simplistic, and they wanted to avoid banks and avoid the regulatory. So that if there are certain areas where there was a consensus you wanted to get away from that central party, but I think that central party often is a very powerful player, and they're not going to give up power easily. In fact, one of the things I found really funny is you look at all the stuff on this, like, oh, blockchain distributed, it's going to revolutionize stuff, and new players, and then you look at who's putting it into it. It's all the big players. It's all the very highly funded, powerful IT companies and banks are saying, yes, of course we want to take over this. It will give us some efficiencies, and in fact we'll be in an even better position to quash the smaller players. So, I think when you look in Hawaii, how could it be used? It can be used to reinforce the status quo in areas where the powerful players have the control of the status quo, whether it's financial transactions, real estate transactions, or it could be used to eliminate a middleman. But I don't know. It's interesting.
It's intriguing. I know. So I was thinking maybe you can buy a car, you can buy and sell a car without going to DMV. Would that be helpful? I don't know.
Yes, we have a hated third party that everybody hates the DMV. Nobody likes the DMV. Got it, Jennifer.
my appreciation too loud.
Do you think this would be possible even like not within the whole state, but like specifically at the university? Because all of the transactions that go on within the university, and if it was like from this perspective, I don't know, a smaller case study that some graduate student might do. I talk to my advisor all the time on this.
That's a very tricky question.
Would it be feasible?
Certainly feasible, but you know,
Who would have to buy in?
whether folks are willing to buy into it.
It seems to me an area that could be ripe in the near future for some kind of transformational thing would be credit reporting. Because, you know, with this horrible example of Experian really blowing it, and the more we look into it, the more we see, like, they really just didn't think they had to take care of it. And then, do we have any more trust in the others? And yet, as many of us would like to go in and freeze up our credit, that's just going to make life hard. So I could see that, not that we would have totally distributed credit reporting, but if I could see new actors coming in and taking over credit reporting that are built on a different technology that could offer a higher level of identity, of digital identity, verification, but also maintaining those different transactions for us.
One application area, you made me think about it, would be education, maybe, where if you could, what if the hated entity was the university? Was the central, and what I mean by that is, like, you need to have a stamp from one place to say that you have become an expert in something. You get a degree from a place. But what if you could learn something in one place and it gets verified, and you learn something else in some other place and it gets verified, and after you have the right combination of things, you can be verified as an expert, whatever.
Oh, that's
It's
interesting.
Competency-based, like, could be used for competency-based.
Yeah, it's like competency-based learning, but it would be a distributed, sort of verification process from all kinds of actors, and then also presumably would be accepted by lots of different people.
Yeah, so the blockchain provides you with the provenance of all your, I don't know, your skill learning activities, or whoever that certifies that you have this skill or this credential. Yeah, that's an interesting thought. Intriguing.
I know that I've heard people in Hawaii talking about using jumping in Bitcoin as part of an independence thing, and avoid using the dollar.
Ah, okay, yes.
I don't know how powerful that could be if you were saying like big actors are buying in and my squash anyway the actors. So I don't know if that could be actually an effective use.
Yeah, by the way,
some people actually does it with that in time.
Yeah, Bitcoin got legally accepted in Japan, so it's a legal form of payment.
But I
And
mean,
China's crushing it.
Yeah, China is the opposite, right? They're trying to crush it.
but I mean, basically, you have to have real entities, those offering products and services, willing to take the Bitcoin, because then by taking the Bitcoin, they could then buy other products and services. So if you try to say, legislate that you have to take Bitcoin, now all of a sudden
It's centralized.
It's a state agency again.
Yeah.
Is Amazon going to start taking Bitcoin?
A few places. Expedia takes Bitcoin. Newegg takes Bitcoin. There's a bunch of internet sites that take Bitcoins. In fact, I was walking in the Manoa marketplace just the other night, and there was one shop that had a sign that said Bitcoin accepted.
Wow.
I'm not sure if it's real or not, but I didn't try it. But yeah. So the other thing is, what about buying a house? I mean, buying a house involves so many parties. It's like, I wonder if something that's blockchain based could help with that.
But a lot of those parties are doing verification, so you would still have to involve them.
Yeah.
So it sounds like the technology just provides you with shared database,
In a way, yes.
and that's it. So anything
Yeah.
that you need the shared database for, then you can
Yeah.
apply it.
Yeah, in a way.
I mean, within the university, I taught Splunk. So if you just need a database that
Yeah.
everyone can see.
That's why I think blockchain is a very specific. There are very specific conditions that makes it attractive. I think, like I said, I think the management of the trust issues. I think that's a big part of it.
So could we use it as like the siphon system?
The what?
You know, the siphon system to redistribute resources, like haves and have nots.
No, I thought about that. Yes.
So
Last question. Maybe.
I always thought one of the clever things about Bitcoin is the incentive to mine, right? And people make money by
Correct.
consuming, turning electricity into hash price, basically.
Yeah.
And so all of the technology you talked about is really about the distributed database. It doesn't talk about the
The
sort of
incentives. Yes.
decision making, who gets to generate, who has to generate, how do we balance, competing interests.
Yeah, because for the private blockchain, that's gone. The private blockchain.
It's not though, because you're talking about entities that don't trust each other.
Yeah. I mean, it's not
That's-
completely gone, but as in gone is in the crypto mining part is gone.
Right, that I believe. But you need some other mechanism.
Yeah,
to-
but there are a bunch of different mechanisms. There's and this is in the literature as well. Proof of stake, proof of what is that one? Proof of work is this one. I think there's one more, and then it's basically. But then in order for it to be easily used by different companies, they want to make it configurable. So it becomes messy. Let's put it this way. I think, yeah. But it's a good point. It could be a good research topic.
I think certainly for people in this room, that would
Yeah.
be a central thing that,
Correct.
who decides,
Yeah.
who gets to add things under what conditions.
Agreed. How are we doing on time?
Well, probably pretty much finishing up, and we don't have any other questions. Thank you very much for great talk.